Okay, great. So we won't really cover anything totally new, right? So what I do want to do though, especially for the students who haven't verified what they're doing for um, for their assessment, let me just quickly check again. Let me just open that here. So particularly for the students here, so I just want to verify, right, what everyone is doing. So I have Julia, Hanbin, so I know what Ida's doing, Andrew as well, I think. Yes. So Andrew's doing anger. Sophia is doing depression. Jay is doing anger as well. Wang is doing depression. Rosie is doing Rosie is doing anger, was it? Or was that depression? Sorry. Let me just check. So just checking. Yep, it's all good. Sorry, depression for both Rosie and Adam. Okay, so going back, depression for both Rosie and Russian, and then depression also for Adam. So let me just finish this through. So lots of people do using depression. Random depression as well. Nisar gets depression as well. I think that's it. Not quite sure if I'm missing anyone, but okay, that's fine. Okay, so what I really want to do today is perhaps just see if you guys have any questions. But you know what? I'll just cover a few things, right? So again, reminder that at this stage, right, you already have a chosen idea or a concept that you're visualizing. You're just going to visualize that. It has to be at least 15 to 25 seconds long. So maybe 15 might be okay. That means you have some sort of narrative there. Okay, so that's correct. Again, our process is poster frame. Then you're basically implementing it at this stage, right? So these are the options that you have. Not quite sure who's doing greed, um, but I think most of you are doing anger or depression, so that's good. Not quite sure. Yeah, that's right. So most of you are doing anger and depression. Okay, so we'll just cover additional techniques, and I primarily just had a look. Okay, sure, no worries. I'll have a look at all of your stuff as soon as I can. I'll just cover some techniques, perhaps that a lot of you can, can probably help. Can probably use. So first up, environment fog. Okay, because some of you are using environment fog, particularly for the depression one. So maybe let's have a look at how you can perhaps approach environment fog. Right. So as I mentioned, environment fog. So basically, you guys have a grid there. Let me just close a few things there, and maybe you scatter some points on that, and then you have some sort of um, I don't know, cube, and then maybe for the cube, maybe I'll just find it like that. So I guess something like that, right? And then I'll just do a copy to points, and then maybe I'll do an attribute adjust um, adjust float, and maybe I'll use p scale for that. can actually use. So maybe I'll just use noise. Then let's see what. Okay. So perhaps along something along that line, and maybe I'll just I don't know duplicate that. For the duplicate, I'll rotate that. Then maybe I'll just reposition. Okay. And I think a lot of you probably have some sort of camera there. That camera is maybe along the Z axis. And then if I look through the camera, lock it, you probably have something like that. And then remember with your camera, everyone, you can have depth of field as well. So we'll just have a look at that later on. And I can even, just to make it wider, I can maybe change the focal length to 35 or even 30. So just to have a wider view. Then maybe I'll just, I don't know. Okay. So how can you? So basically, if you have a look at the concept, I'm breaking it down. An obvious thing that is going to be important here is the environment fog, and meaning what again? It's just analyzing the environment fog, right? In terms of what's happening there. What's happening is the fog is thicker in the background compared to the foreground, meaning as you go forwards in Z, the fog appears to be thicker. And basically, that's an atmospheric effect, right? Where it's because, your camera or those objects are farther away, the particles perhaps are more visible and more, with regards to perspective. That's why it might appear that the fog is thicker further away from your camera. So I just want to perhaps emulate that effect. There's really a lot of ways you can do that. But maybe a common way to do that, right? So I'm thinking maybe I'll just recreate that effect. So what I'm thinking is maybe I'll use a box. Okay. And in that box, so basically I'll just call this fog box. Again, there's really a lot of ways you can do this. But I'll just do it using stuff that we covered. Rather than coming up with something new, it's really just stuff that we covered. So maybe for this one, I'll just make that big. So I'm taking note that it's in the Z axis and maybe make it big. Then make it like that. Okay, so what we can do is we can scatter some points in the box, but rather than scattering it in the surface, I can scatter it inside the box itself. So basically, you do that using some sort of volume scatter, meaning points from volumes. Okay, so basically what it does, see, it just creates those points. Now that's a lot of points. Again, the idea is I can convert those points into some sort of volume or VDB after. I can even just rasterize them to create the volume from that. But again, the idea behind this is, see, I have those points, and maybe from those points, I can just adjust the separation a little bit, and maybe just randomize it by adding some sort of jitter scale, and maybe just jitter seed there. Okay, so perhaps something like that, right? So remember, right? Remember density. We can control density if we have something like a pyro simulation. But the thing is, remember that technique where we can rasterize attributes and convert them into volumes. So basically volume rasterized attributes. So we can rasterize density attributes from points and convert them into density volumes. So that's what we did in the smoke. That's what we did in the fire, right? So what I can essentially do is add some sort of density attribute here, meaning I can have the points here in the background be more dense, maybe have a density of 1 or 2, and maybe the points in the foreground, or basically near the camera, will have a density of 0. So the idea behind it is points nearer the camera will have a density of 0, and then points farther away from the camera will have a density of 1 or 2. So that's the idea behind it. Okay, so how do you go about doing that? Let's have a look at the direction of our camera first. So see, basically our camera starts here. Notice that our I think it's going to the negative Z axis, if I'm wrong. Let's see. So this is the camera is actually going positive Z. So see, so that's positive Z. You can see that. And then all our objects or our points farther away from the camera is going the negative direction. So what you can do is maybe, right? If you want it easier, you can have it start have the camera start at the negative position, but it doesn't really matter. Um, I guess, you know what, maybe I'll just do it that way. Have it start at negative. Um, so basically what I'm saying is I'll have the camera. Again, it doesn't even matter, right? I'll just lock it and maybe have it go the other way. So see? So I'll just have it start from that direction. Okay. Okay, so with that said, okay, I'll just go back to our fog box. Remember, we just want a density attribute, right? So what I can do is maybe I can add an attribute adjust float, remember? And I can just create an attribute called density, okay? So density, right? And again, I can convert or rasterize that attribute using some sort of pyro source. So maybe density there, okay? Now, I actually want to use a float attribute. I want to use the Z attribute or the Z position of, again, the idea is I want to use the Z position of my points. So where they are in Z space. So just to prove my point here. See guys, basically, right? Objects, points that are positive are farther away from the camera. And then points that are negative basically are nearer the camera. Okay. So what I want to do is create my density attribute based off the position of those points in the Z axis. Why the Z axis? Because again, if you have a look at our scene there, so see, our camera starts from here. See, notice that that's the Z axis. It's going towards the Z axis, right? If it's moving forwards, it's going towards the Z axis. If it's somewhere else, if it's starting here, then it goes towards the X. If it's starting from up going down, then it's going to be Y, right? But this one is definitely Z. Okay, so how can I control density using the position Z of my points? What I can do, everyone, is maybe I'll create an attribute, okay, and plug in the position, the Z position of those points in that attribute, okay? So basically, I can just create an attribute. I can even call that, so I'll just use a node called create attribute create. It just creates an attribute. So I'll plug it in here. Okay. It's going to be a point attribute, everyone. And I can call that whatever I want. I'll just call that Z position. Okay. Or Z pos. Okay. So that attribute will be a float attribute, meaning it only has one value, meaning it's not X, Y, Z. It's basically just one um, value there, or a float value. So for the value for that, I'm going to assign the position Z of my points. So how do you do that? You just add a very simple, a very simple uh, piece of, that's not really code, but basically I'll just go at P. Okay, so basically I'm grabbing the position attribute of my points. Particularly, I want to get the Z, which is dot Z. Okay, so basically what this allows me to do is it allows me to grab my position Z attribute of my points there. And then I'll just press enter. Now, let's see if that Z pos is actually equal to my Z position. I'll go to my geometry spreadsheet. See guys, that's Z pos. That's the attribute that I created. See, notice now it's exactly the same as my position Z. So see, now some of you can will ask, why can't you just use the Z position immediately? Maybe here you can't. I mean, for whatever reason, I don't know if it's a Houdini thing. You can't just plug in the at p.y. You have to plug it into an attribute first before you can use it. To ramp things up. Okay. So again, I basically created an attribute called zpos, and I plugged in the position Z of my points there. Okay. So I can now adjust my density based off that Z position by just changing this to, let's say, I don't know, remap attribute. Remember, the attribute I want to use is Z pos. That's the attribute I created. So Z pos, right? And then I'll just compute the range. Okay, so there you go. So notice what happens. Basically, if the Z pos is negative, it has a density of 0. If it's going towards the positive area, it has a maximum value of 1. You can actually change this if you want. You can make it 2 if you want. So basically, it starts at 0. Notice the density. and then all the way down, it becomes so 0 to 2. See? So it starts at 0, and then it goes to 2. But maybe I'll just change it to 1, really. But the idea behind this, everyone, right? The idea behind this is points that are nearer the camera will have, a low density attribute, but points farther away from the camera will have a high density attribute. Okay, so what do we do now? Remember, we can now convert that into a VDB or volume by maybe just using a pyrosource node. Remember the pyrosource node? So pyrosource, we can we can create a density attribute, density, and it just initializes, right? It just tells Houdini, you know what, I'm going to use a density attribute. I'm going to use that for my pyro simulation. But I'm not even doing a pyro simulation. And then it's just keeping the input. Okay. So again, it's keeping the input, basically whatever density attribute you have there, it's just keeping it and then it's plugging that into the density attribute there. Okay. So what I'll end up doing next is just do a attribute. Sorry, that was rasterize attribute, right? So volume rasterize attribute to convert those point attributes into actual volumes. So I'll just go, um, what's that? Rasterize. So volume rasterize attributes. Okay, and then plug that in. Remember, we're rasterizing density. So notice what happens, guys. Now I have something like that. Okay. Now let's see if this works. If I adjust the density here, see, notice what happens. See, guys, I'm making it in such a way that, see, so if you can see it, notice that this is my smoke. See, basically it has a linear interpolation. So, but if I make that 0 at the start, notice what happens. There's barely any smoke at the start. And then you have basically accumulating fog towards the horizon. See? So hopefully you can see that, right? So again, the idea is you have accumulating fog towards the horizon. Okay, if I look through my camera, notice now that I get, I can modify that a little bit, but see, so that's the smoke on the horizon. But if I just slowly bring that in, see, now I actually have more smoke or more fog, compared. So more fog in the, on areas farther away from the camera compared to areas near the camera. Okay, so I guess I have something like that. Okay, so you guys remember what you need to do next. Um, Again, you don't even have to simulate, right? Maybe you're happy with the simulation here. If you want it moving a little bit, I guess you can just do a volume deform. Um, so what? How? Just easy way of deforming. So deform. So volume. I'm thinking volume deform or volume noise. I think so. There's volume noise fog, and then I'll make that multiply, and then see if I can just animate that. Zero centered animation, turn it on. So see, notice now that it is animating a little bit, and maybe pulse duration. And then I'll have a look at my perspective view. So again, you don't even have to animate it really, right? So maybe I'm happy without it being animated. Okay, so I'll just remove it like that. Okay, so let's see what this looks like rendered. Okay, so what I'm thinking is maybe I'll just create a simple area light somewhere there and plug in the area light maybe towards the horizon. Let's have a look at our camera. Maybe I'll rotate that area light. Not quite sure where it's facing really. And maybe increase the intensity or the exposure. And maybe I'll also do it, actually create two area lights, right? So maybe the second area light, I'll just reposition that somewhere here. Maybe lower down the exposure. Okay, so may I have something like that. I can always adjust that. Okay, so remember how we add a material. If you're adding a material for our object, so matte, remember it's going to be a pyro preview. Okay, and then I'll just call this material matte uh, fog. Okay, and then maybe what I'll do next is, okay, so maybe something like that. Um, and I'll assign a material to all of our other objects. So remember, for everything else, standard surface. So maybe I'll just call this matte OBJs. Okay, so let me just see if I'm actually recording, guys. Okay, there we go. Okay, so I think that's it. Let's just assign those materials. So fog bank, so material. Let me just check if that's a VDB. That's a VDB, so that's fine. Um, so the material is going to be a fog, and then for everything else, material. Just, okay, so let's save this just in case it crashes. And then save this as, I'll just call this week 11. Okay, so what I'll do next is just quickly check if we can render it out. I'll have a look at Karma, and then I'm going to lock this camera. I'll use XPU, maybe lower down the path trace, and then maybe I'll have a look at the Karma viewport. Let's have a look at XPU. And then maybe I'll just lower down the camera effects, filters. So maybe what I'll do, everyone, is maybe I'll just change the fog bank density. Maybe I'll have it max out to 2. And maybe I'll just have this. So it just takes time, right? So, but notice now that if I just play around with, let's say, my light, and maybe, again, play around with my light, intensity, and maybe play around with my color, I might be able to get something, I guess, decent. Okay, now on top of that, maybe let's play around with depth of field. So what I'll do, everyone, save that. Remember, with depth of field, um, look for your camera. Okay, so with your camera, I'll just, let's see where your camera is pointing at. Okay, so I'm looking at my camera. I think you press this button here, and with that button, I think it's Z. Or was that? You right click on the camera, you look for the, geez, let me just check. Oh, sorry guys, it's this one, right? So right click on the manipulator, focus handle, remember? So this area will be in focus. So what I'll do is I'll move the focus area first. Maybe I'll have it focus here. And then this is going to be the depth of field there. So maybe I don't want it totally visible. So maybe something like that. And then I'll need to make sure that for my out, I'll turn on depth of field. So this is my Karma renderer. I'll have a look at, let's say, my rendering, enable depth of field. And then let's have a look at our camera. Make sure that our fog is visible. And then let's have a look at our out. And again, we have XPU. So see guys, notice now the depth of field there is working. So you have, I guess, something like that. I might increase my sampling, sorry, my limits, so I can have more bouncing of lights in my volumes. So basically, if you have more limits on your volume, you'll just get more bouncing of lights, right? So I'm just putting 2 there. So relatively fast. Um, Actually, it becomes lower, so maybe I'll just lower this down to 1. But you know what? That's actually still pretty good. Okay. Again, if you add a few more lights, then that might help you out significantly. Okay, so maybe something like that. Uh, so what can you do to adjust this? This means if you want to refine the look of the fog, that might mean, guys, increase the number of points. So start here. Maybe you can increase the number of points, maybe point 0.2, and then maybe in your pyro source as well, maybe you want the particle scale to be smaller, so 1, and then maybe in your volume attribute, your voxel size, you might want that smaller even, 0.05, and then let's see what it looks like. Okay, so see guys, notice now that you have a finer looking fog there. Um, Again, you can increase the number of the point separation to, let's say, 0.1, 0.15, and then see, so now you have a totally different looking smoke there. Okay, so it's just, I guess, a balancing act. You just have to, I guess, have a look at that. Let's see what it looks like rendered out. So not sure where my renderer is. There you go. So see, so I might need to adjust the lights a bit further as well. Okay. Or you know what? Maybe my density is a bit too much. So maybe I'll modify my material, perhaps. My fog density scale to something smaller. So see, now with a smaller density scale, that's clearer there. Okay. And then, you know, maybe I'll also brighten up the lights as well. Okay. So just checking if that's helpful, if that's clear for everyone in terms of a possible approach for your fog, right? So you just want that volumetric fog um, coming from the scene. So see, you probably want a really small. I'm not even sure if you want a small. Uh, so you don't necessarily need a small particle size. Sorry, guys. So maybe not even a small particle size. I'm thinking maybe make it big. So let's have a look. So maybe instead of having a point separation of, maybe have a point separation of 1, or maybe what, like that. But make your particles big under your pyro source. So particle size, maybe change that to 2, and then your volume voxel size 0.1. So I guess maybe something like that. See, So it's just experimentation at this stage. Okay. So hopefully that's clear. So let's have a look at some other stuff here. Um, so the points, if you use something like Solaris, which is inside Houdini, it's easy to instance points. So instance lights, sorry. So the ideal scenario is you can actually instance lights. The problem is you have to use a different rendering um, window inside Houdini that we didn't cover called Solaris, which is for look development. So rather than covering that, maybe your best solution is to just work with geometry lights. So meaning what I mean by that, everyone, is maybe I'll duplicate that fog back box, but instead of using the box, see, I'll just have that as points, but maybe I'll just have a small number of points. So see, so with those small number of points there, what I can do is perhaps, so meaning something like that, right? Just small number of points. Then maybe I can do a copy to points, okay? And for I'll just use that and maybe copy some sort of sphere. I do have one tip for everyone first, okay? So I know we're using boxes, but if you're using more complicated objects, remember that box has 24 or 8 primitives or 8 uh, points. And then if you, for example, if it's a complicated model like a building, which might have thousands of points, duplicating that or copying that will eat up a lot of your resources and maybe render time. So what we normally do in production, right, is so I'm just saying, right? So just imagine that your building is actually really complicated. So it's as complicated as one of those um, head. So just imagine if it's like a pig head, and the pig head is like 11,000 vertices. Copying that to all of those individual points will eat up a lot of resources. But notice what happens when you use something called pack. Okay, so if I just plug in a pack node, okay, so pack, basically what this allows you to do, everyone, okay, see, notice now this one is 11,000. But notice the moment you pack it, it's going to treat it as just one primitive and one. So basically, it's almost like an alembic. So it's packing it. The problem you have with packing is you won't be able to modify the object itself. Okay? So, but it's going to save a lot of resources, right? So, see, so instead of treating it as an object with 2,000 points, it's going to treat it as an object of with just 1 point or one primitive. So it's basically a USD. It's an advanced concept. It's common in production with universal scene description, but it's treating it as just a basic component, meaning it's almost treating it like a single vertex or single point. Okay, so that saves you a lot of again, the only issue you have is you won't be able to change the color, material, all of that stuff anymore because it's already packed. It's pre-packed, meaning it is what it is. Okay, so if you do want to change stuff, do it here first, then pack it. Okay, so do it here, then pack it. So that saves you a lot of it make and it's Houdini is smart enough to just access the same memory or resource in your computer. If it's a packed object, it will re-access that, same, I guess, slot of memory when it's creating that environment. Okay, so for example, even this one, if it's a simple box, if you just pack it first and then you copy to points, see, notice that that's usually for the final one. See, it's just 1,000 primitives. Compare that to the unpacked one. The unpacked one has 6,000 primitives or points. Okay, so it just saves resources if you pack it. Okay, uh, where were we? Uh, okay, maybe this one. I'll just remove that. But again, caching is also important, right? So the moment you cache as well, the better if it's animated. you won't be able to pack animated objects. So that's the problem. So again, if it's already animated, you won't be able to pack it. Okay. So uh, if it is animated, you have to cache it first, and then I guess pack it. But you can't animate then pack. It doesn't work like that. Okay. We're talking about uh, geometry lights. So as I mentioned, right? If you want geometry lights, maybe just copy to points and maybe just use a, I don't know, a sphere, for example. Again, the ideal scenario is you can instance lights. So you can do a copy to points for lights, but again, it doesn't work with our regular renderer. You have to use an advanced system called Solaris to be able to do that. So we won't be able to cover that, unfortunately. So maybe for this one, your solution might be to just copy points there, copy spheres, point 1 or maybe point zero 0.01. Okay. And then just assign the material, an emissive one. So go to material, and then I'll just assign an emissive material. There's probably an emissive material here that I'm not aware of. So I'm not sure. So maybe, but I only know one. So maybe I'll just go PBR. So PBR, um, not the black body. Let's go standard surface. And remember, this is emissive. Emissive. So that means I'll go specular and zero out the specular. I don't even need the base there. I just need the emission. So maybe I'll make that red, right? And then emission can go beyond 1, guys. Okay, so meaning I can actually have that go to 10 if I want to. So it's really emissive, right? And then what I'll do is I'll assign that emissive material to our geometry. I'll make sure to save my scene. Okay, save that. And then let's see what it looks like rendered out. Um, Term of viewport. So see guys, it is emissive. The only issue you have might be you might need more path trace samples. Or rather than doing that, you can actually convert that on top of that. You can convert that into volumes and have those volumes, assign a. So rather than having an object, right? Let's see if that works. But see, notice now that I have that. Um, so maybe I'll make it extremely emissive. It's not perfect, but let's see. So I have something like that. I don't really want the middle bit. So, but it's no big deal, right? If you don't want the middle bit, it's no big deal. Again, if you don't want the middle bit, it's quite simple. Geometry lights. I'll just turn it off. It's quite simple, right? You just group things. And maybe in that group, just use. So basically, you group everything inside that bounding box. So maybe you don't want to have spheres or points in the middle bit. So you just create that group. And basically, anything inside that group, you know what? I'll actually do it here. So anything inside that group, so it's going to be 4 points. So anything inside that group, just blast it. So blast everything inside the group, right? So see, now you only have points on the top and on the bottom. And maybe I can just increase this. See, so when you blast it, you have that, and then you assign the material, and then let's see what that looks like when we actually render it out. So see, so I just got rid of some of the stuff there. Again, I leave it up to you. This is geometry though, so you might consider changing that. Instead of using geometry, you might want to convert those points into maybe volumes or VDBs. So basically what I'm saying, guys, is you can even take it a step further. So meaning instead of having those as points, right? So copy to points. You know what? I won't even copy to points that. Maybe I'll just do a simple VDB from uh, particles. And let's have the particle voxel size. Let's make it a fog VDB. Okay, so but it's still quite big. So maybe radius, make it smaller. Voxel size 0.03, maybe something like that. But remember what you can do? You can assign it a XPU material. Pyro preview. Um, is it density? So it's density, guys. It doesn't have temperature. But what you can do in the material itself is, see, for fire, basically under bindings, right? It's using temperature for the fire, but you can actually use density as well. So I'll just copy density. I'll plug that into the fire. Okay. So meaning it's not going to be using the velocity, sorry, the temperature. So I'm using density to control the fire, the amount of fire that I'm getting. So haven't they even so again, the idea is instead of using temperature, the reason why I can't use temperature is this is not the simulation. If you have a look here, I converted that to VDBs or volumes, but it doesn't have a temperature VDB. It only has a density one. You can create a temperature one, but I'll just use the density and see if that actually works. Okay, so material, see if that works, and then change that to, let's say, this KM Pyro preview. Not sure if I activated the fire. So maybe increase that and then save this just in case it crashes. And then let's have a look at our camera. And then let's have a look at our render. Camera viewport. Let's go to view. So there you go, guys. So see, now it's actually pieces of fire. Okay. So you just need to increase the temperature a bit more. The problem with that, it will require more render time. Okay. Because it's a volume. But see, notice now that, well, it's actually really too bright. So let me just adjust my material intensity. So there you go. Okay. So the idea behind it is, yes, you can use it as a polygon, right? So we use it as a surface. The problem is it doesn't really give us that nice glow. But if you convert that into volumes and you use the density as its um, as its fire, so basically in the material itself, right? You can bind the density to the fire volume. So now if you increase the fire intensity, you have something like that. Okay? So does that make sense? So I think that's it for this one. Okay? I think that's a lot of tips already that you guys can use. That didn't really take me a long time to render, but it does give me those nice. Again, lots of things you can do with that. You can add some noise. Remember a fog noise to create that foggy, if to change the look of the fire. So see, and you can even add a glow in After Effects as well. So let's see how you guys go. Okay, I think that's it for this one. Let's have a look at anyone who's doing something else. This is like I've taught this subject for like 3 years already, and students always choose depression for some reason. Someone comes up with a depression concept, and then everyone does that. A lot of students do that. So I don't know if it's a student thing. So unfortunately, I'm not making fun of it, but it's it's just something that I noticed. Unfortunately, that's right. Clearly relatable. I understand. Okay. So I think that's. Let me just have a look at what you guys have. Right. So depression is serious though. So if you are truly, you know, undergoing that, that is something serious to be taken seriously. So we do have support around that, and there's also support with regards to the government regards to that. Okay. Just checking with Jason in terms of what you're doing since Jason's here. Everyone else, I think I already listed you in. So just checking with the students who are here who haven't verified what idea they're visualizing. Just let me know. So I guess Jason, if you're able to, just let us know what your idea is or what you're visualizing, or you might have added it already, but I failed to see that reply. So just make sure. So again, if you're watching the recording, everyone, I just want you to message me and just let me know, right, what you're doing, so we can have a look at that. Okay, so I'll just cover maybe a few more. Okay, ADHD. Okay, great. So since we're, yeah, I guess you can, yeah, I mean, lots of things. I guess you can have a look at. You probably want to decide soon, right? Because it is due next week. So I guess think about that. So you know what, ADHD. Let's have a look at maybe things you can explore. Uh, let's see, trails. Let me just have a look. Geometry lights, pyro. Okay. Let's have a look at trails because trails might be useful for ADHD. Okay. So let's have a look at trails. So looking at the concept of ADHD, so you might want some ideas if you are trying to do trails or trying to do those spirals. So creating trailing effects might be helpful. So what I'll do, everyone, is maybe I'll close this. Okay. So I'll give you feedback with regards to what you've guys done. But let's just have a look at one more technique, I guess. Let me just save this. Let me just create a new one. Okay, so I'll start off with a sphere, right? And again, okay, so let's have a look. So maybe something like that. Okay. So let's say it's exploding. So I'll just give you some ideas with regards to trails. Okay, so I'll have this object, and I'll just perhaps change it to polygons, and then maybe increase the frequency a little bit. And I'll just have some particles, particle trails exploding from it. So what I'll do is maybe I'll just have that. Um, so remember, we can use a pop network, right? Plug that in, and with that pop network, basically, if you hit play, it creates your particles for you, which is good. The problem you have though is I want to have those particles emit based off the normal of that surface. So I actually want it emitting outside or outwards, right? So to make it emit outwards, I want to give it an initial velocity, meaning I want the particles to have a velocity that's perhaps equal to the normal of those points. So it'll actually go towards the direction of the normal. So the way to make this work perhaps is I'll add a normal attribute. And the reason this will work is because in your pop network, remember in the pop network, everyone, it will try to inherit the velocity that you assigned in it. Now, the reason why it's not moving at all is because if you have a look, see, there's really no velocity attribute. You only have position attributes, there's no velocity attribute. So we're going to create some velocity attributes. I'm going to add a normal node. And maybe I'll do this for the points. And basically what the normal node does, it just gives you a normal attribute for the points, right? Now, on top of that, what I can do is I can convert those normal attributes into velocity attributes. Again, normal is n. We want to convert those normal attributes because they're pointing in the correct direction now. What we want to do is convert that into velocity attributes. And the way to do that, lots of ways really. You can use coding, but for this one, I'll just use, I'll just use attribute VOP. So basically, attribute VOP allows you to connect attributes inside the VOP. So attribute VOP, go in. So see, this is your input geometry. This is your output geometry. So what that means, I can convert my normal attribute. I can make that my velocity attribute as well. Okay, so let's see what that looks like. Middle mouse drag. See guys, we have a normal attribute, position attribute, and now we have a velocity attribute on top of that. So we're giving it an initial velocity. Okay, so with that said, okay, since our attributes or since our points are basically inheriting the initial velocities we're adding on your object, what happens now is, see, you get that. It's actually emitting outwards, right? Similar to that. Okay. Now that's a bit too many particles. So what I'll do is maybe I'll just go to birth, maybe lower down the number of particles I'm getting, and I'll just maybe change that to 100. And maybe on top of that, I'll have that die in roughly around 5 seconds. So what I'll do is if I hit play, I get something like that. Okay. So relatively straightforward for now, right? You know what? I find that to be too many, so maybe I'll just do 20. And then let's see what that looks like. If I hit play, I get something like that. Now, just to make them move, um, better inside the pop network itself, I'll just add a wind, pop wind. Remember, pop wind. I'll add that here. Okay, and with that pop wind, maybe I'll just change the amplitude and maybe the swirl size, and let's see what that does. Okay, so now I have that, and maybe you know what? I'll just lower down the zero roughness so it's not going to have an additional level. And maybe I'll just change. Okay, so maybe something like that. Okay, there you go. Okay, so what we're essentially doing, everyone, is we just have particles emitting. Okay, okay. So let's just explore what we can do with those points, though. If you have a look at those points, again, particles are points. Okay, so what happens is if you actually go and have a look at those points, although I can see it here, those points will actually have, those are basically points. You can assign attributes to it. You can also do other stuff with it. But I guess, let me just have a quick look. I just want to explore the points there. So see, so basically guys, those points, you don't have to do the null, but anyway, just to see what's happening there. Basically, those points have position. What interestingly though, if you have a look, those points actually have an ID. If I'm not wrong, I'm looking for the ID attribute. So I'm looking for ID. So basically, ID is, see that one, guys. So each single point there has a unique ID attribute, and that ID attribute. So for example, if you're the first point, you have an ID of 0. Second point, ID of 1, etc. Okay. So the important thing is I'm going to use that later on the process. Okay. So what are you able to do with those points? Amazingly enough, guys, you can actually have those points emit additional particles. So what do I mean by that? If you add a pop network after a pop network, basically what will happen is you have those points emitting points. Let me just show you how it works. Go inside the pop network. I'll change the source. Instead of using surface, I'm going to use points. Okay. And now on top of that, I'll give it an initial inherited velocity. But instead of inheriting velocity, I'll just set an initial velocity. In fact, I'll set an initial velocity of 0. So it doesn't actually move. It just basically stays in place. Okay? So let's have a look at our simulation now. Okay? If I hit play, I get something like that. Okay? So the idea behind this is, see, we have our points, right? So these are original pop network. And that pop network is basically, oops. So see, that's basically just individual points. But I added another pop network on top of it, and now the points are emitting points, if that makes sense. Okay, so in this pop network, basically, I have the source set to points, and then I have the initial velocity set to 0. So basically, it emits something, but those points don't actually move. Okay, so what happens is I get something like this now. Okay, so now I have something that looks like trails, right? So similar, I guess, to what you have there. Okay. So what they can do on top of that, everyone, right? Remember, so yeah, so notice now that I have something like that. Okay. Now, what you're able to do though is in the pop network itself, notice that the pop network has under attributes, add ID attributes. For the second pop network, I don't want it adding additional ID attributes. I actually want to use the existing ID attributes. So I want to turn this off. And the reason for that is I want those new points or new particles to just inherit the IDs of their mother points. Okay, so basically these are the mother points, right? So see, those are mother points. They have their own, sorry guys, that's one. Okay, so those are mother points. Basically, they have their own unique ID attribute. So what I want to do is for the new points to have or to just inherit their IDs from their mother. Okay? The reason why that is important is because I have a special node called add. Okay? The add allows you to create lines or geometry. I'll just add that in. And the idea behind that, guys, is see, notice that you can add or create polygons out of points. Now, you can do it by pattern or you can do it by group. I'll actually end up doing it by group. But instead of using all points, I'm actually going to be using an attribute. Okay? Remember, there's an ID attribute, and that ID attribute is the same for the mother and its children points. So if I just use that ID attribute, notice what happens. It actually creates a line. See? So again, see? It's points. Now, if I use that ID attribute, it creates a line. The reason why it creates a line is because, as I mentioned, the add node creates polygons in between points, but we actually did it in such a way that it creates polygons if they have the same attribute name or the same attribute value. Remember, the mother point and the children points have the same ID attribute. That's why you're able to create a line in between them. Okay? So, what does this mean? This means I can perhaps that's already a curve, okay? Meaning I can resample that curve, okay? Or I can just add a wireframe node, okay? Wireframe. So it's not wireframe, polywire. So polywire. Or you know what? Maybe wireframe is fine, but I'll just use polywire. And then maybe I'll just have this as division. Uh, I'll just use polywire. Sorry, wireframe. It's, it's polywire is better, but I just want to save resources. So there you go, guys. Okay. And I have something like that. Okay, so I created again. You can add more, I guess, forces to control those particles. Now, the reason why resample is interesting is because once you sample that curve, remember with the resample, we can add a curve view attribute, so we know the start and the end of the curve. And what we can do is, if you're if you know the start and the end of the curve, basically the start is 0, the end is 1, then you can add things like color. Okay, so maybe attribute adjust color. And maybe I can use perhaps a remap attribute. And I'll remap basically the curve view. And notice now that I have something like that, right? So it starts off blue. and then becomes red and so forth. Or you can even just have different colors coming from your original points. So basically, those are your points. Maybe I'll just add a color, attribute adjust color, and maybe just have that as random. Okay, and maybe I'll do that for the primitives. So see, and now since your particles will inherit the color coming from your object, notice now that the moment you resample, see, I have something like that, right? And if you wireframe that, I get that. Again, lots of things you can do. For example, the pop, see, I can just modify that. Or the wind, I can lower down the amplitude, maybe increase or decrease the swirl size, and then even add, you know, and then let's see what that actually does. So I have something like that. Okay. Okay. So again, hopefully that helps. I wanted to cover one more. Um, I guess the shards. Anyone doing the anger? Uh, so anger thing. Maybe I'll just cover one. But you know what? Before we cover anger, let's just have a look at some of your stuff. I guess. Let's see. So see, I like that. So I like the. So let's have a look at. Sorry, guys. I'm just look. I'm just looking at. I'm basically primarily looking it from here. So you have some shatter test there. Yep. You know what? I'll maybe demonstrate one technique here as well. Again, you can also play with the camera, right? Where you have a close up and stuff like that. But we'll talk about that perhaps later on. Um, I like that as well. Yep. So that's getting there as well. So that's actually looking good. But again, you can even consider doing close-ups, doing stuff that you did in assessment too, where you can play around with the camera, the cuts. Remember, we used um, a switcher, so you can cut between different shots. Right? So that might even make it look a bit more interesting. Um, anger. Okay, see, so that's looking good. I haven't seen the rest though. Let's have a look at. So I like that with regards to the scaling. Again, this requires experimentation. Maybe I'll give you some tips on terms of how you can control the scaling on on a per area basis, perhaps. But let's see first. Yep. So let's have a look. Yeah, I mean, I might not be able to see the stuff here. I'll give you guys feedback because for some whatever reason I can't see the stuff here. Yep. If you can send it again, I can have a look. But see, for whatever reason, I can't see it. Let's see, procedural. Yeah, because I'm using the desktop version. There you go. ADHD. There you go. This one. Ah, there you go. I like that almost handheld look. Yep, you can even make since your scale is very small, you probably want the camera to be slower. So I'll probably end up making the camera slower. So that's looking pretty good as well. Okay. So I reckon you can already start refining the movement of your objects and then maybe start adding those fog and those lights and then just experiment. This scene will help if you do the packing thing. So that might, make that, and the depth of field as well. But again, you don't even need to have it move all the way through because it goes all the way to the end. Because my concern is what will happen in the end here. So in the end, it's probably going to be just a lot of fog. So might as well just have it move slowly. Maybe have it start here and then maybe just end here. See? So basically a slower camera move. Yeah, that's right. So if to make the audience appreciate the scale more, if you add the if you add characters or standing characters there and have your camera move from one character to the next character, that will probably make the audience feel more, if they can probably grasp the size of the scene more because now they have a visual reference with regards to how big the environment is compared to a standing person. So if I'm doing it, I'll probably just have my camera move from one person standing, perhaps to the next person standing, and so forth. Right? So we have maybe not really a close up of that person, but we see that person uh, visibly compared to the entire environment. So if you have, for example, someone there, I can't see if you actually have someone there standing. And then once you add, because again, the person will be important because that also specifies the size of your lights. So remember, we covered the technique with the light thing. So you probably want that either bigger or smaller than the person, but you don't want that to be significantly bigger than the person, I guess. So stuff like that, right? So looking good. Okay. Anyone else? I think so. A lot of you are doing this. As I mentioned, you can share ideas from one another, which is good. Um, and you have different approaches as well. So, for example, this one, I probably won't recommend creating a simulation because that will probably eat up a lot of time. Just do what we had, what we covered. So, see, my concern be if it's a pyro simulation, that means probably need like 100 pyro simulations there, Wang, and that will probably be, it will probably take you a long time to render. But if you use the technique we covered, where you just have those individual points converted into VDBs, and then even use some sort of noise to, you know, create that illusion that it's on fire or something, then that's probably a better solution. So maybe have a look at the recording again. Okay, so that might be faster, I reckon. Anyone else? Before I might cover just one more thing that can help the students doing the anger thing. Let me just check if. Oh, um, okay, great. Yeah, so for depression, yeah, I mean, as I mentioned, right? Perhaps don't do it as a fire simulation because that's going to eat up a lot of. Perhaps treat it as something like. So, see, this is not a simulation for me. See, my geometry lights are not simulations. It's really just the box. So, see, it's basically just points that I blasted, that I converted into VDBs. So now they're individual, I guess, fireballs, if you can call it that. And then I just assigned, but again, those VDB from particles, they only have density. Okay? So the problem with density is for fire to work, you need temperature. But remember, there was a technique in materials where I actually reconnected instead of the fire using the temperature, I actually have it use the density. So that's basically your material. So under bindings, I use density as the fire. Okay. Yeah, but the fire itself, um, the way to make it look nice is to really simulate it at. So basically, you want to simulate really good fire, and then you just basically you simulate it once, and then duplicate that on different points. So it has to look good by itself. That's right. So it's basically some. It's not even fire. That's right. So if you have a look at the reference image, it's actually just point lights. So see, it's not technically fire. Okay. What you can do is see rather than if you want to have a bigger area that's in red, what you can do is see just make another version of this geometry lights. Okay. So another version of that geometry lights, maybe just a few more points. So maybe something like that. And then in convert them to VDBs. Okay, VDB from particles. And then just make sure that the point size is big. So see, so now you have a sphere like that. Okay. And then what you can do is I think you can do volume, noise, fog. And maybe I'll just change that to multiply and then element size. So see, I'm just lowering down the element size and then so just to prevent it from looking too spherical, and maybe I'll just increase the amplitude, or I can even do subtract perhaps, not subtract, maybe set, so something like that. So it's not purely, it's not purely spherical. Or you know what, you can even just, I guess, yeah, I mean, you can add some sort of noise. Okay, anyone else? So again, you have two versions of it. You have geometry lights that are small, so smaller fires, and then you have another geometry lights that are big. Okay, but they're not fire simulations at all. Okay, so you can play around with that. So it's really just breaking it down. So the important thing for this one, guys, is your ability to break down what you actually need. So for example, yeah, the big fire, the small fire. So that's one, two. I even like having those. See, if it were me, I find those building lights to be very interesting. I think I can do that using so rather than duplicating just a simple cube, maybe I'll do something with the cube to have certain parts of it illuminate, or have certain parts of it to be, a different color. So stuff like that, right? Light sources from hitting objects. Good point. You might want to try. Again, it's more of a Solaris thing, but I think the light itself has a mask. I'm not actually sure if it works with. So I'll check out. So I think per light, right? There's, I think, miscellaneous or shadow. I think, let me just have a quick look. Contributions. You can specify what component, but I think there's a masking there as well, so we can tell it not to affect certain objects. So let me just have a quick look. Not quite sure though, but there's some sort of mask perhaps that we can add to the light. Okay. Nah, it's not. It's not texturing. It's basically a lighting thing. You can tell it. Let me just check. It's basically light linking, so you can check how. Um, so light linking. So again, it's usually in lops, meaning it's a different context for look dev. So we might not have that ability in because we're doing simple rendering. Um, let's see. So I might need to come back on you on that. But worst case scenario, you just want to perhaps limit, I guess, the light there. Yeah, unfortunately, it looks like we might not be able to do it. Yeah, yes. Yeah, we can't mask it out. There is light linker inside, Solaris, but it's a bit more, I guess, complicated because we have to learn a totally new way of doing things or doing renders. But anyway, yeah. So basically, light linking is just telling Houdini which lights affect which objects. So we won't be able to do it here because it requires a different context, meaning it requires you to use Solaris, which is their look development. And see, this is a totally different, I guess, way of doing Houdini again. So we're not doing that particular context. So we'll just have to work with what we have, unfortunately. Okay. So we just need to perhaps find another solution. Um, so yeah, so I guess it's just a limitation. Okay, so going back to the head. Okay, so head, template head. So just some tips in terms of how you can make things, I guess, look better. Again, if you're doing a shatter, always a good idea to fill in any holes. So for example, this template head actually has a hole. So what I'll do is I'll actually fill that hole first. So polyfill, because the shatter works. So see, we're just filling that hole. Okay, and that hole is usually problematic when we're trying to shatter it, right? But on top of that, what we're able to do is now we can shatter it. Remember, we can go under models, and now we can perhaps shatter that, right? So shatter, and then I don't really need I don't need interior surfaces for my scatter. Maybe for this one I don't necessarily need it, so I'll just turn it off. And then maybe I'll increase the number of chunks to something bigger. Whoa, it's too much. Yikes. I need to cut this down. So maybe 1,000. Okay. Okay, so basically I have 1,000 pieces there. Okay. So, for example, if you just want the smoke to emit at, let's say, the shattering lines, what you can do is perhaps, let me see, you can divide it. And let me just do it first, and then I'll just explain why you need it this way. Okay, so you're able to divide it. That allows you to just remove. So if I remove share edges, it'll just remove all the edges that we had earlier and just concentrates on the actual Voronoi fracture that we created. And then on top of that, we can use that ends. That ends. Let me just check. I think it's sec. I think it's I remember correctly. So let me just remember. Edges. So sorry guys. I just want to see if we can just keep those edges. I think it's the sec. See. So again, the idea is I just want to keep those edges. I'm thinking it's going to be, um, geez, let me just remember. Ends or what's that? So sorry guys, let me just do that very quickly. Just need to check. Think. Okay, so we unroll it. Jeez. Unroll. Sec. I think it's ends. Yeah, it was ends, and then we just unroll it. There you go. So anyway, the ends allows you to just separate the edges from everything else. So again, a bit weird, but basically, you start off with a fracture, right? And the fracture, you just keep remove the interior edges or interior surfaces, and then you divide it. And basically, the divide allows you to remove shared edges, so it only keeps the Voronoi edges there. And then the ends one just removes the faces, so you're just left with those, you know, edges. And then for the ends one here, we have it to unroll new points because if there's no changes there. But if you use unroll new points, you get just the edges. Okay, so that might be useful. The reason why this might be important, guys, is now you can use those points or edges as your pyro source. Remember, we can now use that as a pyro source. Okay, and now I can keep, and maybe I'll keep it as density. You can use fire, but maybe I'll just use density and velocity. Okay. And from that, I can rasterize the attributes. And then remember, we're rasterizing density and then velocity. And then we just want to make sure that we keep the particle scale small. So maybe 1 and maybe this one. Voxel size 0.01 and then particle size zero point 0.1. Maybe this one, particle size zero point 0.1. I might need to adjust this, but let's add a pyro solver. So it's really too big. Maybe I'll just adjust that. 0.01, zero point 0.01. Ah, okay. The head itself is really big, really small. So I'll need to just increase that by 10. Okay. So again, the reason why it's too small is, see, that's 1 unit. So that's basically, so maybe this one might work. So we divide ends and then we use it as a pyro source and then we rasterize it. There you go. And then we have it play, and maybe we just modify it 0.05, maybe this one 0.05. Okay, and then let's see what that looks like. So hit play, I get something. So we might need to modify that a bit more, but again with the pyro source I can perhaps um, so maybe with a pyro source I can just zero out that one, and then um, maybe on top of that I can just add a volume velocity and then have some sort of curl noise. And let's see what that looks like. So I get maybe an initial velocity of just zero point 0.1. And there you go. So I guess, I get something like that. So it's only emitting on the edges of the Voronoi. Okay. So that might be useful, but you need to modify, uh, you know, modify some of the settings here. Okay, so that might be, I guess, useful. Let me just turn on my display. So there you go. Quick sec, guys. Let me just have a quick look. Sorry, guys. What did I break? Quick sec. I just have multiple stuff open here. Great. Okay, that should be good. Okay, so you are able to do perhaps something like this, right? But what I prefer doing, the only issue I have with this, yeah. So you need a good scale. Basically, 1 meter. So you can actually see that's actually 5 meters. So that means again a simulation that's you can see the screen. There you go. So hopefully it's visible now. Can you guys see my screen? So I just have some. Okay, great, and you can also hear me. Okay, great. So again, that 5 means 5 meters, right? So again, if it's a simulation, basically, if you're simulating, let's say a house on fire, or let's say a pencil on fire, a pencil is just like a few, you know, centimeters. So pencil on fire compared to a house that's on fire will give you a totally different simulation, right? So it is very unit specific. So make sure you're happy with your starting scale when you're dealing with pyro simulations. The only issue I have with pyro simulations, if you do this, is controlling when it starts. So the question is, how do you control when a pyro simulation starts? Yes, you can modify it here, maybe the start time, but let me just show you what I like doing. What I like doing, everyone, is I actually prefer plugging in a pop network first, and I'll show you why. So if I plug in a pop network, because the thing with pop networks is I can easily specify when a pop network or particle starts emitting. So for example, I'll just use all points, and maybe I'll just have initial velocity. So maybe set initial velocity, maybe 0.1 there, and I'll just have that at 0. Okay. So the idea behind this is, see, I have that. Okay. And then maybe I can add some sort of wind. So pop wind. And maybe I'll just increase that. Maybe I'll lower down the number of particles I'm getting to, let's say, 100. Okay. And then maybe I'll just plug it a bit too much. So my wind is a bit too much. So maybe I'll just zero out the roughness. So I guess something like that. Okay. And maybe, you know what, I'll just limit the number of points further. So let's say 20. And then, so maybe something like that. Okay. Again, the reason why I might like this, maybe zero point 0.5. There you go. Okay. So the reason why I like this is because I can control when the particles start appearing and when it starts dying off. So remember, to die off, I can change life expectancy. That's right. So you can do a merge, or you can just specify um, for your collider. And perhaps I'll have a look at that in a sec. But see, I can choose when it ends as well. So see, notice now that it starts at ends at that one. So see, notice now that I have that. Okay. So it starts off with particles, because the thing is, with particles, I can control the life of those particles quite easily, right? I can even choose when it emits. So see, guys, I can choose, for example, to have the constant activation set to 0. Okay. Maybe I won't have it emit until frame 24. So at frame 24, then it starts emitting. Okay. So keyframe that. So basically what happens is, see, frame 1 to 24, nothing happens, but at frame 24, it starts emitting. Okay. So I like that, right? I like the ability to control when the particles actually start emitting. And then when it actually dies. So see, it dies after roughly around 3 seconds. So see, so we know that uh, we can convert particles or point attributes into volumes. Remember? So what we can do, guys, is from the top network, we can just do a pyrosource. Remember? With that pyrosource, I can just use existing. I'll add density, and then I'll add velocity, right? And maybe for my velocity, I'll just add maybe zero point 0.2 there. Okay. Okay. So now notice now that these points also have density in it, and they also have velocity in it. So what I can do now is I can now convert that into or rasterize that into volumes, right? So volume, rasterize attributes. So we're rasterizing. Again, if you want smoke, you just need density and you need velocity. So remember, density and then velocity. Velocity there. Okay? So if I hit play, I get something like that. Okay? So if I run it through a simulation now, let's say a pyro simulation, notice now it's easier to control when it starts happening and when it starts, diminishing. So if I run it through my pyro solver, so let's see. So see, it starts there and it ends there. So notice that I can easily have it start at frame 25 because my particles start appearing at frame 25. Okay, and then it also dies off. Okay, so now I have that. Obviously, you need to modify, let's say, things like your diffusion, dissipation. Yes, but it's a bit harder. So you can use the pyro solver when you can choose what frame it starts. Yes, you can definitely do that, right? But you just have a bit more freedom and control if you use something like points. Okay, so see if I do it something like this, you just have a bit more control because you can also control when it dies. Okay, so I can also control when it dies. So for example, if you need to have it turn off and on within a sequence, this is a better solution because it's much easy to keyframe. Okay. So again, basically what's happening is I'm using points first. Okay. In fact, let me just show you so I can perhaps maybe I'll change it to zero point 0.8 and then maybe I'll change the pop wind to something bigger. Let's see what that looks like. See, so I have something like that. And then I run it through the same thing. So pyro source, then volume rasterize attributes, and then pyro solver. And in fact, I can add a volume uh, velocity. So volume velocity, volume velocity. Maybe add some sort of curl noise, increase this turbulence, and let's see what happens. So I guess I get something like that. And oftentimes when you do particles, guys, um, you just get finer results, so wispier smoke if you do it that way. Because if you have everything emitting, sometimes it gives you that, So see, notice that usually gives me um, a wispier type of smoke if I have it this way. Okay, so maybe zero point zero 0.03 and then maybe zero point zero 0.03. And let's see what that looks like. So see, so it gives me a wispier looking smoke. Okay, so it's only emitting on certain areas. Okay, So the question is, can you have that collide with other objects? Yes, you can. You can copy, I guess, the same head here or polyfill. And then what you can do is you can set up the collision. So quick setup, SDF collision, and then just connect the original one, polyfill here. Okay. And then if I hit play, I get stuff like that. And then yes, you can. So see, it's interacting. So you can merge it, I guess, with the original one. But I don't like merging it. I just want my other object. So see, rather than merging it, everyone, just have it as a separate object, as I mentioned. So see, just have it as a separate object, right? So see, just have it as a separate object. There you go. Okay. So see, notice now you get wispier smoke out of that. Yes, you can separate geometry if you want. Okay. So basically what I'm able to do is I'm able to create wispier looking smoke by just having the certain areas emit points first and have those points create smoke. So notice that it's definitely much wispier. Okay, so think about that, I guess, when you're creating your sequence there. Okay, and I think that's it, everyone. Okay, um, any questions before? Again, next week we'll have it's more of a support class. I think you really have everything you need to be able to. Again, you're supposed to come up with your own original piece of work, right? But you can coordinate and help each other out with regards to solutions on certain problems. So I do recommend you help each other out, figure out ways to perhaps enhance the sequence. Now, I do want to do one more challenge, and basically that challenge is to just give me a work in progress by next week. Okay, so give me a previous or a work in progress, right? By the middle of next week. So this means you have your cameras there. So a lot of you already did it. You can just use Flipbook if you want. So remember with Flipbook, it's really just going here and clicking on Flipbook. So this one, Flipbook new settings, specify the start and end. So maybe frame 1 to frame 200. Specify where you're saving it. Remember, it's a dollar $F3. So maybe Ivan uh, underscore dollar $F3 and then dot JPEGs. Okay, and then specify your camera and then just start creating a playblast or flipbook, and it basically renders out what is visible in your screen. Okay, so hopefully that's. So let me just share that one last challenge with everyone, and I'll put that in Teams. Does that make sense for everyone here in terms of what you need to do for week 11? So let me just plug that in here. So I'm just plugging it. So week 11 challenge, and then deadline Wednesday, week 12, and then plug that in. So this is important so I can just see where you guys are at before the deadline is due. I think most of you are doing well. You just need to, find ways to make it look really good. Okay. So I think that's it. Okay. Any questions before we go? Okay, questions with regards to really depends on what you want faster, really. So if you're doing simulations, really no way around it. With simulations, you cache it, and then once maybe try lower settings with regards to simulations. It's really, especially when you're dealing with pyro simulations. Again, XPU is the best way to render things out. If you're using a lot of geometries, caching it will be your best option. Depends on, are you using a laptop? Loading it. No way around it. If you with loading, basically, so what I'm saying is if you cached it and it's still slow, is that what you're saying? If you already cached it and it's still very slow. If you already cached it and it's already very slow, maybe I'll just give you guys some ideas. Okay? Okay, so what I'm saying, guys, is if you already cached it, right? Let's say you cached your simulation. Again, I prefer that you cache it before you assign a material. So cache it first, then assign a material. So don't cache the material together with your objects. Cache just your objects and add the material after. Okay, that's always going to be better. Okay, so cache the material before adding an object. So just to help you guys, when you already did a file cache, okay, file cache, and you already cached it out, okay, just create another, when you're ready to render, just save everything. Okay, save it as a different scene, maybe for rendering. Okay, or when you're happy with the cache. And then what you can do is you can just delete everything prior to the cache. Okay, and just have just the file cache there. Okay, so again, delete everything, have another version of your scene with everything before the cache deleted. So basically all you have are caches. Okay, and that should be relatively fast. Maybe because you're you have something cached, but you sometimes select another node, and that node will also uh you can disconnect nodes, but the problem is sometimes your issue is even if you disconnected it. So sometimes your issue, right? And let me just show you. Sometimes your issue is you disconnected the node or the file cache from everything else, but sometimes you select a node and Houdini tries to process that node. So that might be an issue. So what I'm saying is if you already cached everything, if you're happy with the cache, just delete everything. No, just create another version of the file. Make sure you have a version of the file where you haven't deleted, the nodes prior. So see, this is what I mean, guys. Even if you already have a file cache, so see, even if you have a file cache, right? And you set that on up and that's working really well, and then you disconnected that like that, and then you accidentally selected that pyrosolver node, it's going to try and calculate again that node. Okay, especially if you accidentally turn on the display there. Okay, so what I'm saying is just to save you that issue, after you cache it out and when you're ready to render, perhaps just create a version of your file and then delete everything prior to the file cache. Okay? And that might help. That will definitely help. Does that make sense for everyone? Okay? So try it out. Okay? I mean, this is really okay. So basically, you'll just discover that later on. Um, you often have really fast machines for this type of work. But again, we can do it with caching. So just delete all of that when you're ready to just test your renders and then or do your rendering, and then yeah, just do it that way, I guess. Okay. Okay, and that's it, everyone. I'll stop the recording. And again, make sure to share your work by next week. And that's really the last challenge. And I look forward to again. We still have a class next week for any questions. But let's see where you guys are at first. Okay. So I'll catch you guys then. Okay, see you guys then. So let me stop the recording.